Okay, we're going to get started. Um, Thank you, everyone. Good morning to those of us joining us, those of you joining us from the West Coast. Good afternoon to those from the East Coast. Um, Thank you for making time for this webinar where we'll be covering advances in enterprise search enabled by AI. My name is Omar Riaz. I'm the Chief Growth Officer for SOCO AI. SOCO is an AI search layer that is plugged into existing search infrastructure such as Elastic and Solr and enables natural language question answering against unstructured text. On average, we improve MRR between 100 and 300%. I'm joined today by Miles Kehoe, founder of New Idea Engineering. A lot of you probably already know Miles. He's a veteran in the enterprise search space, has also worked for companies like Verity and LucidWorks. Miles will help us dig into what are some of the new developments in search and what is the end user experience around those. And then you'll also be hearing from Tony Zhao, the CEO of SOCO AI. Tony received his PhD from Carnegie Mellon in 2019, and SOCO is an outcome of his PhD thesis work. He has presented his papers in over 30 research conferences, some of the most respected conferences around, and was given the prestigious Best and Brightest PhD Award by Microsoft Research in 2018. So we'll just get started here. I wanted to start off by providing a little bit of an intro. I'm the host, so I'll just set up the stage and then hand it over to Miles and Tony to take us from there. We'll have some time at the end for question answering. Feel free to send us your questions via chat, and we'll be able to address them one by one. So starting with why search? So search obviously has important implications for each one of our personal works, but at an enterprise level, what does search mean for us? So as most of you are aware, text data is growing rapidly. I wanted to put some numbers here just to provide some context around how rapidly it's growing. So to put it into perspective, the amount of data we've created from the beginning of 2017 to today is more than the amount of data humanity has created from its inception to the end of 2016. That is it's this massive explosion of data that has led to the need for new ways to find information in the moment that we need it to fulfill some business processes. As you can see from the slide here, 1 trillion new documents created every year, over 170 million user reviews every year. And what all of this means is approaches to search that were perfectly fine maybe 3 years ago are suddenly struggling to keep up. So, it's estimated that employees spend a significant amount of their time, like 20% of their time, looking for and consolidating information. Even after that time investment, over 40% of the time, they're not able to find what they're looking for. And that has some pretty serious implications for the business processes that are linked to those searches. So here's some numbers here that show from a study that was done to show that if we are able to improve information findability, or in other words, search, we may be able to boost employee productivity by 20 to 25%. Those numbers have been around for a long time, so they're not new, but at least they give us an idea of what the potential is if we are able to provide a better search experience for employees. So taking those numbers, it's interesting that one of the important factors that plays into those numbers is the fact that information is spread out across disparate sources. So I've posted a stat here, 61% of employees use 4 or more systems. This is even worse in healthcare, where a survey showed employees were using 10 or more systems. to fulfill business processes in the healthcare setting. So doing some quick maths here, with fully loaded cost of 60K per employee for 1,000 employees, that's 12 million spent on searching and consolidating information. And if we were able to even make a small dent, perhaps 10% in the efficiency of search, we would pay for any search improvements we put in many times over. So I'll share a quick case study from one of our pilot customers, which is Bank of China. Bank of China has a customer service team that is answering questions about credit cards. And typically, the experience has been that customers will call in about questions about a particular credit card product. The agent will, while the customer is on the phone, do a quick keyword search. And if they're not able to find the answer, which a lot of times they won't because there are many policy documents, they're updated frequently, there are many credit card products, they'll ask the customer for their information, they'll call back the customer, and then they'll be able to provide the information that is needed. Now, with the new experience after deploying SOCO, what agents are able to do is ask questions such as, what countries is the Visa coupon benefit eligible for the Elite Business MasterCard offered by Bank of China? They can ask that question in a search box in natural language and be brought back a phrase level answer with the listing of countries. So what that's resulted in is a 30% reduction in handle time and significantly improved customer satisfaction scores for that team. Search has been around a long time. AI has been around for several years. So why now? Why is now the time that search and AI come together to provide such a great experience that hasn't been possible before? There's a couple of reasons. So technology has just become good enough. This is NLP's moment, just like a few years ago, we had the computer vision's moment in terms of big breakthroughs in technology. We're now able to, out of the box, provide question answering capabilities. Google has open sourced BERT, which has gone a long way towards being able to understand context and intent. So those are some of the topics that some of the leading things that have allowed search to now take a step up and be in line with the explosion of data that's happening. From now, I'll hand it off to Miles, who will lead us through what are decision makers in organizations thinking about as they think about search, and what's the end user experience like.
Great, thanks a lot. I'm Omar. Miles Kehoe here. I'm glad you guys could join us this morning. I want to talk just a few minutes about enterprise search today and sort of where it's going. As you can see on the screen, let's go ahead one forward. No, there we go. I've kind of categorized search into 6 sections. Of course, level 0 is no search, and it's remarkable to me the number of Fortune 500 companies I see that don't have any search at all on the public site, and some don't even have it inside the intranet. It's hard to believe in the 21st century companies are living that way, but I find some every now and then, so I hope none of you who are listening are in that spot. Obviously, level 1, you've got no search. There's level 2 is you've got search, but it kind of sucks. It's bad. And that's kind of the search that you buy out of the box. You maybe didn't do a lot of research, maybe just downloaded an open source tool and installed it, and it searches, but it really doesn't do very well, and it frustrates your users and probably the IT people who try to run it. Years ago, there was a technology called term frequency inverse document frequency, which was how relevance was applied for a long time. It is basically a term that is frequent in one document that is rare in the entire set, makes that an important document to search for TF-IDF search. So if it's something that a lot of people are looking for, that's okay, but it's probably not the way to go. And some people said, well, let's go ahead and use TF-IDF and add an ontology or a set of keywords so we can get concepts sort of instead of the terms themselves. That works pretty well. The problem is that it takes a long time. There's no learning going on here, so it takes a long time for people to find stuff. In fact, I know there are people we've worked with in the past who have 5 or 6 links on the desktop, so they know how to find results that they found once and couldn't find again, or are afraid they can't find again. So that's adding an ontology, basically vocabulary. And what's getting really popular now is natural language search. That is, it recognizes the words and the structure of a sentence. So if you actually, some of these you can actually type a sentence and actually understand, or at least find some pretty good results. And of course, what we'd always like to have is the HAL 9000 computer, maybe short of its short of some of its shortcomings. And what that will do, I think, and it will anticipate the queries. And that's actually sort of the technology that SOCO is using. It's the AI that learns over time what individuals like searching for. It'll know where your department is, what you do for a living, who your people are near you, and things you've searched for in the past. That's a really important thing to have there. Let's go on now to the next slide. We'll look into the stages of search. And basically, I've broken these, both e-commerce and enterprise search, there's sort of 3 categories. There's the navigational step where someone logs in, they sort of know they've got what they're looking for, and they'll type stuff in. And as they type stuff in, they'll look at the result list, scroll down, maybe go back and do another search and find something that looks promising. But it's all really keyword stuff. It's not any rocket science, not any learning at all. There's informational data. You will do a search and then you'll drill down to the results. Just sort of poke around, see which results look good, and maybe find an answer there. Transactional is a little easier. That's in enterprise as well as e-commerce. Basically, you identify the best document, and sometimes you bookmark it. Sometimes you just make sure you know where it was, and it provides you the information you're looking for. So one of the things people call us on all the time, they say the search engine we have now absolutely sucks. Can you help us pick a new one? And quite honestly, the question I like to ask them is, you really need a new platform. So many times we've had customers who say, we want to replace this piece of junk. And when I get there, they've got a perfectly good search engine. They've just not implemented it right. So one of the things to really be careful is, before you spend a lot of money changing the engine, make sure it's not the engine's fault, that it's your implementation part. You can do this by reviewing and auditing the content, see what people are looking for, what they're viewing, and ask them for information. This is still just search, though. This is not rocket science. It's just you type in words, and if there's some synonyms that you've defined, you'll get results. But it's not really advanced search. And one of the other things we find with companies sometimes is that when they say we can't get our search to work right, when we take a look, the problem is they picked the wrong platform. There are probably 20 companies out there that make and license enterprise search products, and a couple of open source in there too. Spark and Lucene are 2 that come to mind off the top. They're pretty good, but they don't do much. They're bare bones. Some companies have taken to wrapping around Solar or Lucene and improving the product. Both Lucidworks and Elasticsearch do that with Solar and other technologies. But if you pick the wrong platform, maybe it's time to change platform. In my head, I define the vendors into 3 categories. Basically, the tier 1 vendors, the ones with broad enterprise search presence. They've got a multi-platform product. It's got market penetration, and the company has a clear vision for where they want to go in the future. We're starting to see more and more companies add some of the open source technologies, like Spark, which adds some AI sort of information to the product. It helps a little bit, but it often takes a long time to have it train up enough to be useful. Sort of the tier 2 vendors have a search engine, but it's a limited enterprise presence. Not many people know about it, not many people use it, and it may be a 2nd or 3rd product for the company that's marketing it. Some of these are also Windows only or Linux only, and it's really unclear what the positioning is the company has in mind. It's like, hey, we've got a search engine, let's start a company. And some of them are good, some of them are not so good. Then there's some vendors that are specifically marked at verticals, a specific vertical. For example, some focus on, say, an e-commerce market. Some focus on on web content, maybe SharePoint content, and that's what they do, right? So one of the tricks is, and as I said, people will call us up and say, this platform sucks, help us get a new one. Well, what we often find is that the problem is not the technology, it's the methodology, how they're installing it, how they're using it, how they're approaching it. But the methodology, unfortunately, is generally vendor independent. It is vendor independent. So it's pretty much the same no matter what. So if the search you have now is not working, just replacing it, you might have the same problems. So you get some incremental improvement, hopefully, but it's still not the best. Generally speaking, improvement is not a major expense. So actually going beyond this basic level and paying attention to search can actually help you improve it. You'll be amazed the number of companies we work with that call us in because they've had a problem with search, and one person works on search part-time in the IT department, has never really seen search before. So he or she is in charge of running it, but it comes out frustratingly slow. So as I said, I'm about to finish up, but basically what you need to do, think of your search engine as a 10-year-old. You've got to watch them all the time. You know what they say they're going to do, but you don't really know what they're doing. You have to spend some time, put some investment into it. That's the step that a lot of companies avoid, but that's really key to get search out of the box working. The good news is there's some technologies like the ones that you're about here now from SOCO that add artificial intelligence to search, really integrate nicely with your search engine, and most importantly, the learning applies to the search engine as it comes along. So let's hand over to Tony. Go ahead. Thank you.
Hello, everyone. Thank you for my. So let me talk about how the latest progress in NLP and AI can help to improve search engine in general. So before I get into details about how search engine can be integrated with AI, I want to give a little background on what's new from academia from the latest NLP research. So if you're in the field of NLP, I bet you have heard about this BERT, which is everyone is talking about it, and many people say BERT is a game changer for NLP. And so what is BERT actually? So BERT is a pre-trained language representation with bidirectional self-attention layer that has improved many NLP tasks, and many of them actually achieving superhuman performance. And so what is actually, really, if we put it in a simpler way, so to remember what is BERT, so there are two key characteristics. So first of all, it's a very big model. It's big. And then the second one is pre-training on a large amount of text data. The good news is to train a BERT, pre-train a BERT, you don't have to have human annotation. You just need to have raw text, and it can digest all the text and get the meaning of all the words. So just give you a more concrete examples. So BERT is initially proposed by Google in 2019, and there's a new model called Robata, follow-up work from Facebook. And the model size, you can see it contains 340 million parameters and for each model. And Microsoft yesterday just released a new model with 17 billion parameters. And the BERT and the Robata, they are trained on almost 100 gigabytes of text data. They get from Wikipedia, a lot of novel books, and they have a big text dump, and then train those two models. And training time also takes a long time. You can see BERT takes one good GPU for 280 days. And then the Facebook takes almost 1,000 days to train. But if you're rich, you can have 1,000 GPUs, so you can get it done in one day. But this is giving an idea about how big the model is, how big the training data is, and how long the training process is to get those kind of model running, have a good performance. But why say BERT is game changer? So let me give you a more direct comparison between what is being done in traditional way versus what we can do with BERT or similar model like that. So in the past, if you want to add in any type of AI or machine learning to your search, what you do is you collect a lot of annotated data for one task, and you train a model, then you solve that task. And if you want to solve the second task, you do the same thing over and over again. You have to collect new data, train a new model, and do a new deployment. So it's very tedious and a long-term costly process to have anything working for using machine learning. So with BERT, the new paradigm is it provides a transferable universal representation. So what does that mean? Essentially, it's like you have so through the BERT, through the unsupervised pre-training, you will get this universal model that can have some basic understanding about language in your domain. Then you can apply the same representation to many tasks by just creating a little bit small data set. And you can have a small annotated data set for one for search, a small annotated data set for maybe topic classification. And so in this way, you can have the same model applied to 10 different tasks with much, much less cost. So that's why everyone is so excited about BERT and its potential. And people have shown this new paradigm can easily achieving like 20, 40% improvement over the past state of art. So I guess the more interesting question for the audience today is, does the BERT actually work for search? So the short answer is yes. So there's a very short paper that just run out-of-box BERT on the passive ranking task. You can see clearly there's, compared to the industry standard BM25, there's a 2 to 3 times improvement and very easily. And it's also much better than the previous state-of-art method, for example, the information retrieval net from Microsoft. But there's a caveat. So what's the catch? Just out-of-box BERT, if you apply to search, it's very slow. It takes about 100 milliseconds to process one passage. And that means if you have 10K records in your database or index, it takes 20 minutes to return search results. If you have 1 million passage in your index, it takes 200 minutes to get search results, which is not acceptable by any standard. So what's our approach in SOCO? So at SOCO, we have done a lot of experiments and a lot of research trying to figure out how to use the BERT for search and what's the best way to combine the best of both worlds. So as a result, I think we have found a very elegant way to combine BERT into search. And to summarize, essentially, we can take the full advantage of BERT in terms of accuracy, and then we push all the magic of AI into the indexing phase. And after indexing is done, we'll only output traditional rank feature at the query phase, so that any search engine can digest those query features and then take advantage of BERT for the search. And as a result, it's very fast. We can return a search result in 50 milliseconds, even though we have a 1 million index record. And even you have 10 million index record, it will only also be within 100 milliseconds delay. So just give you a quick, example here. So essentially, in indexing time, our BERT model will process all the passages and output some sparse factor that can be compatible with traditional Lucy index or Solar index or Elasticsearch index. So those numbers can be easily saved as a normal data feature and then used at the query time. And beyond that, because we now have this AI ability, we can actually do much more than compared to just document-based full text search. And many people say document full text search is boring and slow and inefficient. So what's more on that? So actually with SOCO, you can easily get a natural language question answering system, meaning that you can, if you want to have your Siri for your own enterprises, it's very simple. It's actually the same indexing process, just using this Kehoe version of the BERT or SOCO BERT to indexing all the documents. Then immediately you will get a real-time Siri system that can answer question. For example, if you asking question when what platform do we support in our product X, and then it will be able to looking through all the documents and find out the sentence where say platform X can be integrated with SharePoint, Dropbox, and Gmail, etc. So those are easy to creating serial-like conversational search or question answering without any additional or human annotations to achieve that. So let's look at some numbers. So here is a comparison on 3 popular data sets that's widely used in the information retrieval community. So the first one is Microsoft macro data, which is the Bing query data. And then the second is Google natural language question data. That's also from real Google search. And the last one is the track car data, which is very common used in the information retrieval community. And to compare SOCO with a baseline BM25, and the first column is actually running actual performance from the default Elasticsearch, and then the second column is our number. So you can see that there's clearly a 100 to 300% improvement in all those data sets with negligible actual compute, which is 50 milliseconds for query. So these are really amazing results, and we are really happy about that. How easy it is to apply BERT or SOCO BERT to improve research results across a wide set of data sets. So let's take a little bit deeper into the model, see what's actually happening in the hood, what's the magic, what makes the SOCO bus so can improve performance by that much. So one nice feature about our approach is we actually achieve both the good performance, but also explainable AI, which is not included in most of the AI system. So let's see one good example. So when we're trying to index in one sentence, which is, Bill Gates as American business magnate, software developer, investor, and a philanthropist. So what kind of a process is doing in the backend? So given this sentence, our SOCO bot will convert the sentence into a number, almost 1,600 non-zero features. And those, I'm showing some example of a highly ranked feature in the feature space. So you can see that actually the first top ranked feature is who. That means that, if someone's saying who is the founder of Microsoft, this sentence will return as a top answer, even though there's no Microsoft or who appearing anywhere in the sentence. And then the second category is you can see all the key terms like Gates, investor, magnet, developer, they are all highly ranked in the feature. So that those key terms can be, it's similar to the concept TF-IDF that Mile mentioned, but it's all automatic. And then the coolest part is also including common sense and word knowledge. So you can see the one of the top ranked word term here is actually Microsoft. So Microsoft is not mentioned anywhere in the sentence, but because Bert has read so much text before, it knows Bill Gates is the founder of Microsoft. So that it actually, if you mention about Microsoft, this sentence will also rank high. And then lastly, the either part is you can see it also to discover all the synonyms, the variation, the plural, non-plural version, all automatically without any manual construction. So the benefactors, investors, developers, they all become rank high in the sentence. So that gives you some idea about how the BERT model can improve text because it's encoding all the variation language, but also it encoding the word knowledge. It knows about Microsoft is related to Bill Gates, and it also know about Bill Gates as a person. So if you say who something, then this should be probably a good answer to that. So lastly, I want to talk about how the SOCO can our system can nicely fit into the search pipeline. So we envision ourselves to be a layer between application and data sources, but more concretely, in the search pipeline, we essentially is a special index process that can be run in parallel with other indexing process. And essentially giving data sources, we can run the text, digest all the text. The machine will read the text and output the special feature that we provided. And that feature is also compatible with search engine so that at the client side, you can just do the normal query, but get a superhuman SOCO results. So it's a very easy way to plug in this thing into existing search engine without disrupting the existing flow. So to sum up, and and about AI side, so I think BERT is a word that I think everyone should know by this time, and it's a new paradigm for NLP. And out-of-box BERT has good performance, but it's very, very slow. And the SOCO BERT can achieve three nice features at one time. So good performance, real-time response, and explainable AI. And also it can easily extend beyond search, give you conversational search or question answering system, or this type of a voice-based interface without additional effort. And lastly, it can be easily be a part of the indexing pipeline. So I think that concludes the presentation today, and we'll open the floor to questions, and feel free to type in the chat box.
Thank you, Tony and Miles. Hi, everyone. We're unable to hear you. I can open that up, or you can use the Q&A feature to ask questions. You can in the Q&A feature you can just type your question, and we will answer it. Okay, so we have our first question coming in. So the question is, our domain is healthcare. We have a special technical jargon. Do you think BERT is going to work with that jargon? I'll hand it off to Tony. Tony, you want to take this one?
Yeah, that's a great question. So I think out-of-box BERT maybe not working very well on the healthcare domain, but the nice thing is, as I mentioned, to train a new bird, if you want to train a house bird, it's actually very easy. You just need to get a lot of text in the health domain, and then you don't have to have any human annotation data on that. Just kind of feed those healthcare raw text into the new bird, and then you get a health bird. And then that bird is supposed to understand the technical term very well. I hope that answers the question.
Great. Thank you, Tony. We have one more question. So you said all the work is done at indexing time. How long does indexing take?
Yeah, so the indexing time will definitely be slower than the query phase, but it's still reasonable. So we estimate about 5 to 10 seconds to process one document that contains 5,000 words. So it will take a few hours to process in thousands of files, and so but it can be it's a process can only need to be done once up front. So it's reasonable to handle most of the data sets.
Thank you. We have another question. Can we fine-tune BERT or SOCO to manually train the system?
Yes, so because BERT is a learning system, so it's designed to be trained. So the out-of-box performance will be reasonable, but as you have the real use case, real query from the user, and those data can be the the small fine-tuned data set that I mentioned that give you more personalization for search experience, especially if you have different data from different departments. Then if you just fine-tune the same model on those different departments, then you have really personalized experience for each department or by each function, job functions. Yeah, so I think that also answers the second question, where if they're the human in the loop to manually improve system. So if you can annotate a small subset data, we discover that if you annotate about 500 documents with maybe 10 questions for each document, the performance jump, you can already get 20% performance improvement compared to the default performance.
Thank you, Tony. Miles, I have a question for you. So can you talk a little bit about the implications of adding an AI layer to an existing search implementation such as Solr, and sort of what are things to think about while doing that?
Thanks a lot. Yes, basically, the ability to use technology is sort of based on what the search engine you're using have. Almost all of them now have something that some call an indexing pipeline as well as a query pipeline. The indexing pipeline is obviously something that's going to crawl through all your content and make that searchable. When you then are doing searches, essentially you fork off to both the search engine, and then BERT will come in, SOCO's product will come in and edit the list before you get it. So it's microseconds to get time. There's a very slow delay, a very small delay, but you get the feedback from both. The search says, here's the documents. SOHO says, here's the documents that are important. And it works pretty well. More and more search technology is having an indexing pipeline and a query pipeline too. And by the way, that's an excellent place to actually be able to glue the technologies together. It becomes quite easy, and I think it's really an elegant approach to connecting the two technologies together.
Great, thank you, Miles. Any other questions? I know we're coming up on the 40-minute mark here. I'll leave it open for a minute or so. If there are any other questions, please use the Q&A feature to type them. If you'd like to follow up and have any other questions later on, our information is here. We'll also share these slides with you via email, and also share a link for the video so you can go back and refer to it. Thank you all so much for your attendance. We really appreciate it, and would love to hear from you and your thoughts on what we're doing at SOCO and the direction that search is heading with the new AI capabilities. Have a good day. Goodbye.